Hello everyone and welcome to my YouTube channel. So for today's video, I want us to look at this past paper question. This is the beta past paper question, Automotive Electrical, April 2021. So this was written, I think in 2021 April. So we're going to skip the first part, which is part A, the definitions part. We're just going to start with the second part, part B, which has a calculation. So the question reads, the electric lighting fixture weighing 15 newtons hangs from point C by two strings, AC and AB. So we have point C here, and then these strings here where we have T1, T2, and T1 there. Okay, so the string AC is inclined at angle 60 degrees to the horizontal and BC at angle 45 degrees to the horizontal as shown. Okay, so the first thing that we're going to start with is we're going to draw a free body diagram or a force diagram. So we have forces that are acting on this body that is hanging. We have tension forces in the strings, and we also have the weight force, the weight, which is the weight of the body. So we can start with, if we are to draw our body, we have forces that are acting. We have one in that direction and another one that direction. So this is T1 and this is T2, and then we have the weight force, which is 15 newtons. Okay, so this one is acting at an angle of 60 degrees, and then this other one 45 degrees. And then we know that these forces, the ones that are acting at this angle, which is these angles which are not 90 degrees or 180 degrees, they should have some components. So let's write the components first of all, so as to make it easy for us to simplify these forces, because it is not possible for us to add the forces the way they are. Like this, the only force that we can work with is the weight force, which is acting at 90 degrees downwards. So here we know that we have a component in that direction, which is T1 y, because it's a vertical component, and another component in that direction, which is T1 x. Okay, even here we have a component in that direction, which is a component of T2, so it will be T2 y, a horizontal component as well, which is T2 x. And these two components, they have the x component and the vertical component, or the y component. They represent, or they have the same effect on this body as these forces that are acting at angles. So for example, this force has got these two components which have the same effect, and this force has got these two components which has got the same effect. So we can redraw our diagram with the forces that are acting like this. So we have a force in this direction, which is T2x, this one, and we have a force in that direction, which is T1x. We have the weight force, which is 15 newtons, and we have a component in that direction, which is T1y, another component in that direction, which is T2y. Okay, so since these are horizontal and vertical forces that we have here, it is possible that we can come up with two equations, considering the body is in equilibrium. So since the body here is in equilibrium, there is no movement, it means the conditions for equilibrium will apply. So the conditions for equilibrium, so conditions for electrostatic equilibrium. So the first condition is that the summation of all forces should equal 0, and then the other one is the summation of all moments should equal 0. So under summation of all forces, this means summation of all horizontal forces should equal 0, and summation of all vertical forces should equal 0. So from this, we can make our equations from the forces that are acting there. So the first equation will be this one here, where the summation of all forces should equal 0. So this one, for this one, we're going to get all the forces in the x-axis. So for example, we have T1 and T2. So these are acting in the opposite direction. So T1x minus T2x should equal 0 because they are going in different directions. So this is our equation 1. And then the other one is for the vertical forces. So we have 3 vertical forces there. We know that these two, the ones that are going upwards, so we're going to take the ones that are going upwards to be positive. So it will be T1y plus T2y minus 15, since it's going downwards, is equal to 0. So this is our second equation. That now here we have to find what Tx and Ty are in terms of the force that is acting, or the forces that are acting. So for example, for T1 here, we are going to have the components for T1, and we know that the horizontal component is always associated with the cos. So T1x, we also have T2x, then T1y and T2y. So T1x will equal T1 cos the angle at which T1 is acting, so which is 45, cos 45, and then T2x will equal T2 cos the angle at which T2 is acting, so 60, and then the vertical one will always be associated with sine. So T1 y is equal to T1 sine 45, and then T2y is equal to T2 sine 60. Okay, so we can replace these in our equation, or in our equations. So this one, the first one will be, we use a different pen. The first one will be T1 x is equal to this, so it will be T1 cos 45 minus T2 cos 60 is equal to 0. And then the second one will be T1 sine 45. This is 45. 45 is it minus, plus T2 sine 60 minus 15 is equal to 0. Okay, just write this one properly. So this one is 45. Okay, and then we solve these simultaneously. So we know that we can make the first equation, on the first equation we can make T1 or T2 either T1 or T2 the subject of the formula. So we're going to make T1 the subject. So here we're going to have T1 cos 45 is equal to, so when T2 cos 60 crosses the equal sign, it will be positive. So T2 cos 60, okay, so over cos 45 over cos 45. So this one and this one will go, and then here we're going to remain with T1 equals what is, I'll just do this, okay, so cos 60 divide cos 45, go to that, okay, 0.707, and we can write 0.707. So this one will be 0.707 T2. Okay, so this is our expression for T1, and then sorry about that. Okay, so let's now solve for T2 using the other equation. So we have, use this equation, T1 sine 45 plus T2 sine 60 minus 15 is equal to 0. But we know that T1 is equal to 0.707 T2. So where we have T1, we are going to replace with that. So here we're going to have 0.707 T2, then times sine 45 plus T2 sine 60 equals, so 15 is going to go this side, so when it crosses it will be positive 15, since it's negative 15 this side, equals that. So let's see if we punch this on our calculator, what are we going to have? So okay, so we still have that same number there, so we're just going to say answer times sine 45, what is it going to give us? Okay, so this will be 0.5 or half 0.5, and then plus sine 60, okay, so we have 1.366, so we have 1.366 T2 equals 15. Okay, and then divide 1.366 divide 1.366, so this one and this one will cancel, and our T2 will equal, so 15 divide our answer. Okay, so our answer will be 10.98 newtons. So our T2 is 10.89 newtons. Now, coming back to this expression for T1, we can say T1 is equal to 0.07 times 10.9 newtons, because T2 is 10.9 newtons. So our T2 will be, so answer times 0.707, and we'll have 7 points. So our T1 is 7.76 newtons. Okay, so that is our T1, and that is our T2. So we have T2 and T1. So we can solve this equation using another method, which is we can solve this question rather using another method which is called Lami's rule. So let's look at this other method, which is Lami's rule. So for Lami's rule, we just have to identify the forces that are acting and the angles between which they are acting. So we have forces that are acting like this. We know that here we have 15, and then there we have T2 and T1 there. And let's do this. So we just have to find the angle that is here. Sorry about that. We just have to find the angle that is here, the angle that is there, and the angle that is there. And then we are set to go. So let's see what angles we have here. So we know that this is angle 90 and that is angle 90 there. So if we have 60 here plus 90, we're going to have 60 plus 90 is 150, and then 90 plus 45, we're going to have 135. Then whatever will be here will be 180 minus this minus that. So 60 plus 45, it will give us 105. 180 minus 105, it means we are going to remain with 75 here. So we have 75, 150, and 135 there. So if we put these here, we know that we have 75 and then 150. You can write it here, 150 and 135. Okay, so according to this rule, which is Lami's rule, it says we can start with the weight force. So the weight, which is 15 over sine, the angle that is opposite to 15 will be 75. Sine 75 is equal to T1, for example, there. So we have T1 over the angle that is opposite to T1 will be sine 150. It should also equal T2 over the angle that is opposite, sine the angle that is opposite to T2, which is 135, like this. So according to this rule, we are able to find the unknowns, provided we have 3 knowns. So we can use these two. We can say, okay, so we can say from here we can make T1 the subject. So we cross multiply, we're going to have T1 sine 75 equals 15 sine 150, and then over sine 75 over sine 75. So this one and this one will go. Our T1 will equal, what is 15? What is 15 sine 150, 15 sine 150, divide sine 75. Okay, so we have that. So it will be T1 is equal to 7.76 newtons. So that is our T1, and then our T2. For T2, we can use the same equation. The same equation here. We'll have 15 over sine 75 equals T2 over sine 135, and then we cross multiply to make, since we want to make T2 the subject, so we're going to have T2 sine 75 equals 15 sine 135, and then over sine 75 over sine 75. So this one and this one will go, and then our T2 will equal, see what we have here. Okay, so we have 15 sine 135 those divide sine 75. Okay, and what do we have here? We have 10.98, so 10.98 newtons. So we have the same value. So it just depends on which method you are comfortable with. So that's it for question B. For question 3A, 3B rather, for question 3B. Okay, let's look at the other part, which is part C. So part C says a uniform beam is balanced as shown in the diagram. Calculate the distance. So the distance that you're talking about is this one here, x. So we have a beam, we have forces that are acting. Let's draw that again. So we have 80 newtons, and then we have 120 going in that direction, and then we have 40 newtons, so 120 and 20 newtons going in that direction, and then we have the distance. So here we have x, about that. So we have x here, and then we have 0.9 is the whole span there. Okay, so since this body is balanced, or it's in equilibrium, we know that the principle of moments, or the conditions for equilibrium, will apply. So one of the conditions for equilibrium is the summation of all moments has to equal 0, which is also called the principle of moments. So this one, we know that the moments in the clockwise direction have to, about a certain point, or about an axis of rotation, has to be equal to the moment in the anti-clockwise direction or the same axis. So if we are to identify the forces that are acting here and their moments, we know that this one about this one is wants to turn this in this direction, and then this one also wants to turn this in this direction, and then this one wants to turn the beam in that direction. So if we take moments about this point here, we can call this one point. Is there any point? Okay, we can call this one point P here. So point P. So we take moments about this point. I mean, the moment for this force, which is 120, will be 0 there, so we don't have to consider it. So taking moments about point P, we're going to have this moment, which will be, because moment is given by the force times the perpendicular distance, that. So here, we're going to have the moment for this one. Since it's going in the anti-clockwise direction, it is considered to be positive. And then this other one, which is going in the clockwise direction, is considered to be negative. So the moment about point P there will be the force, which is 80 newtons, times the distance, which is x there. So here we're going to have 80 times x. And then the moment of this other force here about the same point will be 40 times the remaining the remainder of the distance, or the remaining distance there, which is, oh, sorry, this is 0.9. So this one here will be 0.9 minus x, like that. So even this one we are going to have minus, because it's going in a different direction. So this will be 0.9, I mean 40, will be 40 times the distance, which is 0.9 minus x. So this should equal 0 there. It should equal 0. Okay, so here we're going to have 80x, yeah, then minus 40, because this is negative 40 times 0.9. So negative 40 times 0.9 will give us okay, so negative 40 times 0.9 will give us negative 36. So minus 36, and then plus, because we have negative 40, and then we have negative x there. So it will be negative 40 times negative x, which will give us plus. So here we're going to have plus 40x. So this should equal 0. So we can take this 36, because we have 80x and 40x. So this is 40 here, 80x and 40x. We can add these, then 36, negative 36 can be taken on the other side there to give us positive. So here we have 80x plus 40x equals positive 36. Then 40 plus 80 plus 40 there, we have 120. So 120x equals 36. And then solving for x, we divide everything by 120. In here by 120. So our x will equal, what is 36 divided 120? 36 divide 120 is equal to that. So answer here is 0.3. Now the distance was not given, the units for the distance there was not given, whether it's meters, millimeters, it's just 0.3. And there we have our answer.